Hey YouTube! Today I am refreshing a couple of brake rotors, and these are for a Porsche Boxster. The problem here is the guy who owns it, he's a track day fanatic, and after about 5 laps he is experiencing vibration in the steering wheel, and he's changed basically everything in the front suspension, and the strange thing is that it doesn't show until about maybe 5 laps into the run. So that leads me to think that these brake discs are not warped. And I've actually had them up in the lathe to indicate them, and they are not. So the problem, I think anyways, is that the surface has been running hot, and there are some spots on it that looks totally different from other parts of the disc. You can see here you have a couple of spots. There's a big one here. And probably what's happening is that the brake pads are taking gripping unevenly on the discs, depending on the surface of the disc. So that would create vibration, and these discs are really nothing worth at the moment, because they're virtually unusable. That's the amount of vibration they cause. So what I said to the guy was I can try and refresh all of the surface using lathe and probably a carbide tool. I'm not making any guarantees of whether it's going to be better or worse, but it would be pretty interesting for me to try and make this and check with him afterwards how he's experiencing the refreshed surface. So I'm gonna put it up in the lathe, indicate them really thoroughly, and first take this side on both the discs and then flip them around, and that side on both the discs, then flip them around and do the other side. I've kind of preset my jaws here, and I think this is going to fit pretty well. I will also be making a follow-up video on this project, so everyone will know how this job really turned out, if it did actually work. Pretty good. I'm gonna start by indicating the outer diameter of the disc. And that's good enough for the OD. Now we're going to do the inside part where the brake disc is connected to the wheel hub. And that's really going to be our starting point, because that's the important part. Pretty good. I think we got it right there. Just gonna tighten up the jaws a little bit. We have one little variation, is just around this hole, and I actually think that's the surface in here that's not completely true. On the other part of the turn, it's very, very nice. So we'll call that good, and we'll be able to start doing some turning. Okay, so we're gonna put a new insert in, and this is the WNMG Sandvik inserts, and this is the 432s. Been running these for some times, and they work for most of the work I do, and I'm really liking this insert, so I'm gonna continue. And since my lathe is a turret lathe, it's got these protectors over the ways, so the dust is not going to affect it very much. I could of course use a towel here to pick up most of the dust, but I am a little scared of it getting caught in the chuck jaws, so I've decided not to use that option. All right, so we're gonna do, first of all, we're gonna do a little test cut, just to see how it works. I might have to move the tool holder because I can't get to the outer edge of the brake disc. So I'll do that first, and then we'll start up the lathe and make a little test cut. Okay, so we're ready for a test cut here, and we're going to be running at a fairly low RPM, and keep the feed down a little bit. I think I'll start on 224 RPMs, and I'll put the feed rate to 0.125 millimeters per revolution, and we'll just take it from there. Yep, still very nicely indicated. And I think I'll start by taking off maybe 0.2 of a millimeter. We'll take another 0.2. I'm going to try and speed it up just a little bit to 280. See if we can get rid of some of the chatter. Right, so we'll try to speed it down instead. Try 180. Well, that's very much a reasonable finish. There's still some marks of chatter out here, but it does look like it's leaving a reasonable finish, and that's when now I'm running at 112 RPMs and a feed rate of 0.25 millimeters per revolution. And this time I was taking 0.2 millimeters. So I'm gonna make a finish cut now. I'm gonna try 0.1 millimeter. And hopefully that's gonna leave a good finish. It really does seem to get better as I bump the feed rate up. So you kind of push the tool just a little more. Well, that did seem to work pretty good. There was some chatter on the outer edge, but it was very little, and I hope that this surface will be good enough. Okay, that's actually a very nice finish. I can see some chatter marks out here on this part here, but I can't really feel them. That's kind of a first. Usually you can feel something and not see it, but it's a good finish, and I hope it's gonna work. So I'm gonna just chamfer these edges, and we'll get right to the second brake disc. I'm very happy with that result actually. That's better than I expected. It's going to be really interesting to try this out and see how it works. Well, it's the same thing on this disc. We have it running very true, but at one point there we have a little dent. It's just by the V. That's good right there, and we'll turn that surface.